Welcome friends, I'm Professor Andrii Bondarenko, and on this channel we unpack the power, mechanics and science behind heavy industrial machinery. I'm glad to be your guide through the engineering marvels that shape our modern technogenic world. Today we will focus our analysis on a highly specialized type of equipment, dredging machinery. Dredging machinery is defined as a specialized class of floating vessels, amphibia or submerged mechanical systems designed to excavate, lift and transport sediment, rock, sand and mineral deposits from beneath the water's surface. Operating via hydraulic suction, mechanical digging or a combination of both, these industrial units are essential for waterway maintenance, harbor deepening, coastal land reclamation, and shallow water mining operations. Dredging machinery is defined as specialized equipment, whether floating, amphibious, or submerged, used to excavate and move materials from underwater environments. Its core working principles include hydraulic, utilizing high-power suction pumps and water jets, mechanical, utilizing buckets, grabs, or cutting tools to lift solid materials. The primary functions of dredging machinery are shallow water mining of sand, gravel, and mineral ore deposits, navigation channel and harbor deepening for maintenance dredging operations, land reclamation and coastal protection. Dredging machinery is classified into two primary categories based on the method used to excavate and lift material: mechanical dredgers and hydraulic dredgers. Mechanical dredgers physically rip or scoop material from the seabed using steel buckets or grabs. They operate similarly to land-based excavators and are ideal for cohesive soils or rock. Hydraulic dredgers rely on high-power suction pumps to lift material as a water and soil mixture called slurry. They are optimal for loose materials like sand and gravel. To truly understand the evolution of dredging machinery, we have to look back to the year 1861. This was when the world's first mechanized dredger, the mud milling machine, was designed and constructed by Herbert Prince and deployed in Antwerp, Belgium, for harbor clearing. It featured an endless chain of scoops powered entirely by horses walking inside an onboard treadmill. This fascinating piece of 16th century engineering laid the direct foundation for the modern bucket ladder technology we use today. Let's briefly review the design, purpose, working principle, and applications of these mechanical and hydraulic dredgers. First, the Clamshell Dredger, also known as a grab dredger, is a mechanical marine excavation unit equipped with a heavy dual scoop bucket suspended by steel cables from a revolving crane mounted on a pontoon or barge. The primary goal of a clamshell dredger is the vertical extraction of heavy, cohesive, or highly variable underwater materials, including stiff clays, gravel, and large debris, from depth where rigid arm excavators cannot reach. This machine operates in a cyclic four-stage process, driven by gravity and steel cables. Phase 1 is the drop, Phase 2 is the clissura, Phase 3 is the lift, and Phase 4 is the discharge. Thanks to its vertical operation, the clamshell dredger is extensively used for deep water port and harbor maintenance, precision dredging near docks and bridge piers, clearing heavy industrial debris, and excavating deep underwater foundations for civil engineering projects. Let's move on to the next type of mechanical dredging equipment, the Dipper Dredger, widely known in modern engineering as a Backhoe dredger. A Dipper Dredger is a heavy-duty mechanical excavation unit consisting of a powerful hydraulic or cable-operated shovel arm mounted on a floating pontoon or barge. Unlike the cable-suspended clamshell, this unit features a rigid boom and stick configuration, allowing it to apply massive downward force. To maintain stability during operation, the barge is anchored firmly to the seabed using heavy vertical steel pillars called spuds. The main purpose of a Dipper Dredger is the excavation of highly compacted materials, rock, stiff clays, and boulders from shallow to medium depth. It bridges the gap between land-based excavation and marine dredging. This machine operates in a precise high-power cycle. Phase 1 is positioning, Phase 2 is the dig, Phase 3 is the lift and swing, and Phase 4 is the discharge. Dipper dredgers are extensively used for hard rock channel deepening, harbor expansion in rugged geological conditions, undersea trenching for pipelines and cables, and the extraction of heavy industrial debris during structural demolition. Let's continue with another classic type of mechanical dredging equipment, the bucket ladder dredger, also known as a chain bucket dredger. A bucket ladder dredger is a continuous action mechanical excavation vessel. It features a heavy structural framework called a ladder that pivots vertically through a central well in the pontoon. The main purpose of a bucket ladder dredger is the high volume, non-stop mechanical extraction of loose to moderately dense material, as well as a heavy alluvial deposits. It is the premier machine for mining heavy minerals, gold, tin, sand, and gravel directly from riverbeds or shallow marine deposits with high precision. The operation of the bucket ladder dredger is a continuous mechanical cycle that includes 4 phases. Phase 1 is ladder positioning, Phase 2 is continuous scooping, Phase 3 is elevating and dumping, and Phase 4 is separating or barging. Bucket ladder dredgers are heavily utilized in alluvial mining operations for gold and tin extraction, large-scale harbor and river deepening projects where soil is compact, and aggregate production in dedicated sand and gravel quarries. Now let's turn our attention to the second major category of underwater earth-moving, hydraulic dredgers. Hydraulic dredgers are specialized floating vessels or submerged systems designed to excavate and lift material by converting it into a fluid mixture. They use high-power centrifugal pumps to vacuum underwater sediment as a slurry, a mix of water and soil particles. The primary purpose of these machines is the high-efficiency continuous extraction and transportation of loose and fragmentable materials over long distances. Unlike mechanical dredgers that requires barges to move soil, hydraulic units can transport material directly via pipeline. To loosen the soil in underwater conditions, the machine uses either high-pressure water jets or a rotating mechanical tool. The loosened material mixes with water, is sucked into the intake pipe, passes through the onboard pump, and is discharged through a floating pipeline to a reclamation area or into a cargo hold. Hydraulic dredgers are the industry standard for large-scale land reclamation, coastal defense projects, deep shipping channel creation, and high-volume mining of sand, gravel, and industrial minerals. Hydraulic dredgers are classified into 3 main types based on how they lose and store material: plain suction dredgers, cutter suction dredgers, and trailing suction hopper dredgers. One of the highly specialized types of hydraulic dredgers is the jet pump dredger, also known in industrial engineering as an ejector dredger. The slide shows the jet pump dredger designed by myself. This machine is used for mining coarse gravel from deposits in Ukraine and on the Lofa River in Liberia. By the way, this jet pump dredger is capable of extracting coarse gravel with a particle size of up to 180 millimeters from depth of up to 8 meters and transporting it via slurry pipeline over a horizontal distance of up to 250 meters. Jet pump dredgers are exceptionally effective in specific mining and civil engineering environments. They are the premier choice for extraction highly abrasive materials like sharp quartz sand, heavy gravel, and diamond-bearing gravels, which would quickly destroy standard steel pump impellers. When we talk about the absolute peak of modern marine engineering, one machine rules the waves. The title of the largest and most powerful mechanized cutter suction dredger ever built belongs to a true ocean titan called the Spartacus. This massive self-propelled vessel stretches 164 meters in length and packs an unbelievable total installed power of more than 44,000 kilowatts. The Spartacus colossal cutter ladder is driven by a massive 12,000 kilowatts dedicated motor. This heavy steel arm can crush and excavate solid undersea rock at depth of up to 45 meters. Running on eco-friendly liquefied natural gas, this giant is single-handedly reshaping global shipping lanes and building the ports of tomorrow. Today's topic was dedicated to the power and mechanics of dredging machinery. I'm Professor Andrii Bondarenko, and on this channel we unpack the power, mechanics, and science behind heavy industrial machinery. I'm always glad to be your guide through the engineering marvels that shape our modern technogenic world. If you enjoyed this video, don't forget to hit the like button, subscribe to the channel, and share your thoughts in the comments below. If you have any questions about dredging machinery, drop them down there. I'll be happy to respond. Thank you for watching, and I'll see you in the next episode as we continue exploring the secrets of heavy machinery.